points. Whoop, whoop. All right, let's do this. This is your team test 12. And we see complete conjecture that describes the pattern in the given sequence. Okay, we see this. Depending on if we're going clockwise or counterclockwise, this could be different. So let's see what it says. The shaded section in each circle has moved blank counterclockwise. Oh, we're going counterclockwise. That means I went back one, right, and then back one again. So what's it doing? The shade has moved either once, or we could say one section. Counterclockwise, right? From its previous location, which means the next one says use your conjecture to find the next term in the sequence. Okay. Well, if I'm moving back one, it should be right here. So that would be this guess right. Oh, can't see it. That would be this guess right here. Okay, because it moved just back one from here. Back, which matches this right here. This obviously has two shaded, doesn't work. This has two shaded. This has none shaded, doesn't work. So there we go. All right, let's look at 3. Fill in the blanks using the available answer choices. Complete the conjecture about the relationship of NP and PQ if P is the midpoint. Well, P of NQ. Well, P is the midpoint, then NP equals PQ, right? Let's find that one. NP equals PQ. Boom. Right here. And again, I expect that you've paused this, that you've gone through this as much as you can, and you're looking at this now to fill in missing holes or just to find out what the heck's going on. Select whether the conjecture is true or false. If you have 3 points, A, B, and C, then A, B, and C are non-collinear. I'm going to tell you that's false, and here's why. A, B, and C could be collinear. If you can find even one thing to make the conjecture false, it's false. So there we go. This is 4A. I'm assuming there's a 4B happening up here. Give a counterexample. Well, let's look. That's not a counterexample. Those are non-collinear. So are those aren't even A, B, and C. These are non-collinear. Oh, here's collinear. That's counterexample. Or there was always a conjecture is true, but it's not. But if you're in a spot where they are, that's what you would answer on the test, right? Okay, these I left the blanks in because I thought they might help just understand what it's going for. So first, use the statements to write a compound statement for the conjunction or disjunction. Then find the truth values. Okay, so first, let's go ahead and just identify if these are true or not. -3 minus 2 is -5, so that's true. Vertical angles are congruent. That's also true. 2 plus 8 is greater than 10. No, 10 is not greater than 10. 10 equals 10. So that's false. Okay. Now let's fill these in. It says P and Q. So P is -3 minus 2 equals -5. Okay. And then and. Remember that stands for and. So blank one is and. All right. Vertical angles are, or that's supposed to be are congruent. Are. P is, what is it, true? Yeah, we already said P is true. And Q is also true. So P and Q is true. Because remember, for a conjunction, that P and Q both have to be true for this whole thing to be true. And they are, so it is true. Awesome. Let's keep going. Basically, we're using the same setups here. But now we're going to do Q. Remember, that's an or negative R. And for or, only one has to be true. Both can be true, but only one has to be true. So let's see what it is. Q and not R. Notice that's not R right here. That's important. Because if I were to write that down, not R would be 2 plus 8 is less than or equal to 10. And that's true. So let's see. Vertical angles are congruent. Or, right? This one's an or statement. 2 plus 8, oh, we got to fill that in, is less than or equal to 10. That's kind of advantageous that we wrote that. So that's the opposite of greater than. Q is true. We already established that earlier. And not R is also true, right? So Q or not R is true. And really only one had to be true, so Q or R would have been true, but it's extra true now, right? Awesome. Identify the hypothesis and the conclusion of the statement. Assume H and C are the hypothesis and conclusion. Okay, we can do that. That's not hard. So, if two angles are adjacent, then they have a common side. So my hypothesis is right here. It always starts out with that. Two angles are adjacent. And we can say they have a common side. That is the hypothesis and the conclusion. Okay, we're just identifying them. We're not saying much about them right now. Let's go to 8. Identify the hypothesis conclusion, then write the statement in if-then form. Now we're going a little extra. Everybody at the party received a gift. You may be thinking, what's the hypothesis and conclusion? Well, I'll tell you. The hypothesis, and really this C right here goes down here, right? Conclusion. So, hypothesis, I am at the party. Or you could say you are at the party. Just making it all about me. And my conclusion is, I received a gift. Or you received a gift, right? However you did it. It should be EI, right? I before E except after C. So what are we going to say? If I am at the party, then I received a gift. Oh, right there. So we're just identifying hypothesis, conclusion, and writing down the conditional. Now we're going to do the inverse, or the converse, inverse, and contrapositive of a true conditional statement. Determine whether related conditionals are true or false. Okay, so if two angles are complementary, that's the hypothesis. Then the angles are acute. That's the conclusion. So we want to write the converse, which means we're going to flip them around. Converse, if the angles are acute, then the two angles are complementary. Counterexample, you have two acute angles, and the sum of the measures of the angles is not 90 degrees. So if we have two acute angles, like 13 and 5, those add up to 18, that's not 90 degrees, right? The converse is false. So when we flip it, the statement becomes false. Now this statement's true to begin with, though, because if two angles are complementary, it means they add to 90. They have to both be acute, because if they add to 90, acute means greater than 90. So you can't have even one of them be acute or obtuse. Otherwise, you're in trouble. Or even equal to 90, right? If two angles, now we're going to do the inverse. So we're going to do the opposite. We're going to do it in this order, but opposite. So if two angles are not complementary, then the angles are not acute, right? Are not acute. Counterexample, you have two acute angles, and the sum of the measures of the angles is not 90 degrees. Again, if two angles are not complementary, so we're going to say we have two angles that are not 90 degrees, again, 13 and 5. But then it says the two angles are not acute, but both of those are acute, right? So it doesn't work. the inverse is also false. Now let's talk about the contrapositive. Contrapositive is where we both flip it and negate it, right? So the contrapositive is if you have two angles that are not acute, then the angles are not complementary. Okay, now that is true, and here's why. If they're not acute, it means at least one of them is either a right angle or supplementary. And if it's a right angle or supplementary, then the other angle, they are not complementary. And that is true. They can't be complementary. They can't add to 90 degrees, right? Because one's already 90 or above 90. So they can't add another number to it and make it 90. So the contrapositive is true. Look at that. Sorry, I had to do some thinking in my head. All right. Another fill in the blanks. A lot of those on this test, right? Because it's just trying to get to the truth of matters, writing those statements out. Determine whether a conclusion is valid based on the given information, select valid or invalid, and explain your reasoning. If the figure is a square, then it has four right angles. Figure ABCD has four right angles. Conclusion, figure ABCD is a square. Now, here's the thing. That's invalid. Because we're saying it has four right angles, so it could be a rectangle, right? It doesn't have to be a square. Figure ABCD is a square is not the natural conclusion. The figure could, oh, look at that, that's our choice. The figure could be a rectangle. All right? Now, it's important to note that when using, so this was trying to use the law of detachment. If it would have said, if a figure is a square, then it has four right angles. If this last statement would have said, figure ABCD is a square, we could then conclude that it has four right angles by the law of detachment. The hypothesis validates the conclusion, but the conclusion does not validate the hypothesis. That's how it works.